Welcome to In 5 Minutes. In this video clip, we will solve one numerical. The question is, for a discrete time system, its system function is given as h of z equal to 3 minus 7z inverse plus 5z raised to minus 2 upon 1 minus 2.5 z inverse plus z raised to minus 2. So it's a discrete time system, and we will obviously take it as discrete time as well as LTI. So it's discrete time plus LTI system. We are given system function, which is also called transfer function, and the question goes something like this: find output y of n for an input of x of n equal to u of n with zero initial condition. So initial conditions are not given. In simple words, initial conditions are mentioned to be zero. We are given the input signal, we are given the transfer function of the system, and we have to find out output y of n. Now let us see how this question can be solved. We will obviously solve this using transform domain approach. We all know that y of z is equal to, before that, we all know that y of z is equal to nothing but x of z multiplied by h of z. H of z is given to us. So if I can find out x of z, I will get y of z also. X of n is equal to u of n. So all I have to do is take its z transform. X of z becomes z upon z minus 1, and therefore I can now write down y of z. So y of z will be nothing but z upon z minus 1 into h of z is 3 minus 7 z inverse plus 5 z raised to minus 2 divided by 1 minus 2.5 z inverse plus z raised to minus 2. So what we have got is y of z, and now I will have to take its inverse z transform. To take the inverse z transform, we will go through couple of important steps that we have discussed in one of the previous examples also. I'll convert everything into positive powers of z. So this first term is already with positive powers. In the second term, I'll multiply and divide by z squared. So multiply by z squared to numerator as well as to denominator. The numerator will become 3z squared minus z inverse into z squared will be 7z plus 5, because z square z raised to minus 2 will cancel out, divided by z square minus 2.5 z plus 1, because this is just z raised to minus 2 multiplied with z square will give you only 1. Further, this will be, now see, this whole thing is already in the standard form. The coefficient of z square is already 1. So I will write down the numerator now, combined numerator, which looks something like this. And denominator we will have to factorize. The first factor we already have z minus 1. Now if you factorize this quadratic polynomial, the factors will be nothing but z minus 2 and z minus half. You can easily factorize such type of quadratic polynomials in your calculator by solving this and finding the roots. The roots will be 2 and half, so the factors become z minus 2 and z minus half. The next step, if you remember, was taking partial fraction expansion, but only after you have divided by z on both the sides. So if I divide by z on the right hand side, it will cancel out with this z, so it gives me 3z square minus 7z plus 5 divided by z minus 1, z minus 2, z minus half. Please note that you can only take partial fraction expansion if the degree of numerator is less than degree of denominator, which is the case right now. The numerator degree is nothing but 2, and you can say denominator degree, because there are 3 factors, denominator degree is 3. So because numerator degree is less than denominator degree, we can take the partial fraction expansion. If that is not the case, you'll have to first divide numerator by denominator using long division procedure and write everything in q plus r by d form, and that r by d can be taken for partial fraction expansion.